Hi, welcome back to our winter weather YouTube series, Whether You Want to Know or Not. This is the last installment of the series, so I'm just going to be going over some frequently asked questions that we get. The first question I want to answer is how to program your NOAA weather radio. Now, this isn't winter specific, this is important all year round, but we do get this question still in the winter. So, how you change the settings on your individual weather radio is going to vary based on the brand you have. So I'm not going to go into each and every brand and how to set the frequency on that. You can get more information at this link, and I'll put this down in the description. weather.gov/AKQ/NWR program. It's going to give you some information about the program, and at the bottom you'll see a bunch of brands, and you just click on the brand that you have, and it'll take you to a page where you can find some more information about your specific weather radio and how to change the frequency. But that's not a lot of good if you don't know what frequency to put it to. So let's go over how to find the correct frequency for where you are. First, you're just going to go to weather.gov, and you're going to come up here to where it says information there in that red box in the top banner. You go up there and click on that, and it'll take you to a page that looks like this, and you'll see the NOAA weather radio icon there. Click on that, takes you to this page, and then up here at the top where it says coverage, hover over that and a drop down menu will come up, and you'll want to select the county listing option. That's going to be the easiest route to take, and it's going to take you here, and you select your state that you're in, and it'll take you to a page looks like this, and it'll show you that station ID and the frequency to turn it to here for your county. So easy enough, just a few clicks away, and you'll find your frequency, and you can get the forecast and be able to hear what kind of watches and warnings we have out, if we have any out. All right. The next question I'm covering is, why don't we forecast snow totals more than 3 days out? If you watched the How to Check Your Forecast video, I went over that you're only going to be able to find snow total forecasts through the first 2 to 3 days. Let's talk a little bit more about why that is. The key word here is uncertainty. So the farther we go out in time, the more uncertain our forecast is. And this is for a bunch of reasons, mostly that our science and our weather models just aren't there yet. It's something we work on, but a lot of times, the storm systems that we're forecasting for that are going to bring us snow or ice don't even exist yet. If it's more than 3 days out. So it makes it very difficult for us to get a really good forecast and a really good idea of how much snow we're going to get. So we don't forecast snow totals out that far, mostly just because, if we put out a snow forecast that far out with not knowing enough information, it could really come back to haunt us. It's just not useful for our partners. It's not useful for the public, really. So the best thing that you're going to get in the long term, other than just maybe, 40% chance of snow, is looking at those long-term weather impact graphics. And you can find more information about that in the How to Check Your Forecast video from this series. Okay, and the last question: why is forecasting snow so much harder than forecasting rain? You probably see all the time cases where there's been a forecast for one amount and a completely different amount happened at your house, and you're wondering why. You're wondering, what are they doing up there? Well, hopefully I can give you a little insight about what makes that so different from just forecasting whether or not it's going to rain. So there are a lot of moving parts to a snow forecast. There are a lot of things that go into it. First of all, to get a snow total, we combine the liquid total, how much liquid is falling from the sky, plus the snow ratio. So for every, say for every inch of rain or that we would get, or inch of liquid, that correlates to, let's say, for example, 10 inches of snow. That snow ratio changes depending on the air mass that's in place and how dry the air mass is. You can find a little bit more information about that in the dry versus wet snow video. So we have to get those exact. So if either of those is incorrect, your snow total is going to be incorrect. The other thing is timing. Timing is very, very important. First, we have to time when that precip is going to come in, and we have to time the temperatures. And if those two things don't line up just right, it can really throw off a snow forecast. What if the precip starts at 4 in the morning when it's 30 degrees versus 10 in the morning when it's 36 degrees? That makes a big difference, obviously. So if we're off by a degree or two or an hour or two, it can throw off your forecast. And we have to try to time the transition from rain to snow or vice versa. And as you can imagine, that can be pretty hard to do, especially when a lot of it comes down to the exact position of a low pressure system or a storm system. If the models don't have that just right, if we're not anticipating that just right, if it shifts 50 to 100 miles in either direction, that could mean the difference between a bunch of snow and a bunch of rain. So that can be really hard to nail down. Also, the presence of snow bands or snow squalls. Snow bands are these long, relatively skinny bands of snow, and it's nearly impossible to get an exact location of where that snow band is going to set up. So let's say we're anticipating a snow band setting up somewhere in the forecast area, and our best guess is that it's going to come over your house. So when you look at the forecast, it says that it's going to be 10 inches of snow, and you wake up the next morning and there's only 4 inches. And you're thinking to yourself, what happened? What the heck? Where's my snow? Well, it's probably about 20 miles to the west. That's just an example. If you don't get that placement of the snow band correct, that could really throw off the snow totals as well. The other thing is pre-existing conditions. So if it has been 70, 65 degrees for the last week, and then all of a sudden we have this really strong storm system coming in, and it drops the temperatures really fast, and a bunch of snow comes in. If the rate at which the snow is falling is not high enough, it won't accumulate. But if the snow rate is high enough, if it's coming down fast enough, it can overcome a warm ground. We have to anticipate how fast the snow is going to be coming down. Lastly, most models are not high enough resolution to capture every element affecting snow totals. So like I just went over, there's a lot of moving parts here to a snow forecast. We do our best, and we do a pretty good job most, if not all, the time. So, but sometimes our guidance, our models, our weather models are just not helping us out at all. A lot of these moving parts require fine detail in the models that a lot of models just don't have. And if they do have it, they only have it out, 24 to 48 hours. So that's why forecasting snow is so much harder than forecasting rain. Well, that's about all I have for you today. And this is the last video of this Whether You Want to Know or Not series for the winter edition. If you have more questions, please comment them below, and we will try to answer you in the comments. Thank you so much for watching, and enjoy the rest of your winter.